Welcome to BME channel, and the topic of this lecture is amplitude modulation, and we shall deal with the mathematical treatment of amplitude modulation. So this is the topic of amplitude modulation that I will be covering just now. It is the process in which the amplitude of high frequency carrier wave changes in accordance with the instantaneous value of the modulating signal. Now there are two parameters. One parameter is carrier wave. Carrier wave is a high frequency wave. Its amplitude is to be varied with respect to modulating signal. Modulating signal is the information signal. So we shall be having two signals now. First, I will just create a modulating signal. Modulating signal is this. Let us take a sinusoidal modulating signal. This is represented by MT. MT is equal to AM sine omega MT. Now in this mathematical expression, MT is the instantaneous amplitude of the modulating signal or the information signal that is to be sent. AM is its amplitude. Sine omega m is the angular frequency of the signal, and t is the time. So this is made clear here. AM, amplitude of modulating signal. Amplitude of modulating signal, omega m, angular frequency of the modulating signal. Similarly, we shall be having sinusoidal carrier wave. We shall be having sinusoidal carrier wave. Here, sinusoidal carrier wave, as I have already told that it's a high frequency signal. You can say AC is the amplitude of that carrier wave, and omega c is the angular frequency of that carrier wave. Here AC is amplitude of the carrier wave, and omega c is equal to 2 pi mu c is the angular frequency of the carrier wave. Now you can just make use of these two figures. For example, this is the modulating signal. Modulating signal is given by MT. Now even I will write here modulating signal. This is the modulating signal. I will exactly write equation here. This is the modulating signal, and the equation is MT is equal to AM sine omega MT plus phi. This is the signal. Here it is, we haven't taken phi into consideration. Why? Because we are taking initial phase gap 0. So we are taking initial phase gap 0, and the equation here is omega MT. This is the equation. This equation is meant for this curve, which is the signal that is to be sent. On the same wave, this is the carrier signal. This is the amplitude modulation. This is the carrier signal. The carrier signal is, I am representing this by CT. This is equal to AC sine omega CT. In amplitude modulation, now understand it very carefully. We have to vary this AC. This AC is constant. Amplitude of carrier wave is constant. See, this height is same. Now I have to vary this AC with respect to what? With respect to this MT. With respect to this MT. Now what we shall be doing? We shall be doing here. Now I will just make one change here. As waves are directly in front of you, CT is the carrier wave. Look at this expression. This is CT is AC sine omega CT. Now this is the amplitude modulated wave. The amplitude of the equation for amplitude modulated wave will be, now the carrier wave or the modulated wave will be Ct. Ct will now become, I will see the notation first, it is Cmt. Ct is just the carrier wave. Ct is this carrier wave. Ct is this carrier wave with amplitude AC. Mt is modulating signal with amplitude AM. Now making a for creating a modulated wave, what I shall be doing? Now I have to change AC. AC is what? AC is the amplitude here, this amplitude AC. What I will do, I will just make addition here and write equation as CMT. CMT is the modulated wave and the diagram of that wave is here, and its amplitude will now be AC plus MT. This is the amplitude of the modulated wave, and with this amplitude, rest part I will let it remain the same. Sine, inside I shall be having omega Ct. This is amplitude modulation. Compare these two equations. One equation is this. Compare this equation with this equation. If we compare these two equations, what we get? Again, this equation and this equation. Here amplitude was AC. Now here amplitude is AC plus MT. And the next remains the same. Note it down. This is sine omega Ct. This is sine omega Ct. Here it is M. Just take it as, you assume it has to be M. So this is what we got here. Now, again, carrier wave, modulating wave. This is modulated wave. In modulated wave, we have changed only amplitude. That is from AC, which was a carrier wave. Amplitude of modulated wave is AC plus MT. Now I will proceed here for further mathematical calculation. And once more, look at this. This is carrier wave. This is modulating wave. Amplitude of carrier wave is constant here. Amplitude of modulated wave is this. It varies. It varies in accordance with the displacement of the modulating signal. So finally we got this as modulated wave. Now there is a bit of a small mathematical treatment that I will do here. This CMT, is AC, amplitude of original carrier wave, plus we have added MT in it, and finally I am substituting the value of that MT here. Sine omega MT. And now whole of this is to be multiplied by sine omega Ct. Now we will take AC as common, that is amplitude of carrier wave as common. We will get 1 plus AM, amplitude of modulating wave, divided by amplitude of carrier wave, and here I shall be having sine omega MT. Omega M is the frequency of modulating signal. Whole of this multiplied by sine omega Ctc equal to this is, I will take AC as common, and inside we shall be having 1 plus mu AM by AC. ratio of amplitude of modulating signal divided by amplitude of carrier wave or carrier signal is mu. And then here I have got sine omega m t into sine omega ct. Now I will open the bracket. So in modulated wave, I have got AC sine AC. I will keep it out. I will keep AC as out. This is, I will take it out of the bracket, and here I shall be having AC omega ct, one frequency which is carrier frequency, plus I shall be having mu into sine omega c t into sine omega mt. This is the equation. Now I will take AC as common. Now look here very carefully. AC as common. Here I shall be having sine omega ct as it is plus mu. Here we will play a trick. Mu divided by 2. We have got a formula. Note it down. Twice of this formula is written here. I will show you directly from the notes. This is the formula. Sine A sine B is 1 by half cos A minus B minus cos A plus B. I shall be making use of this formula. So if I make use of this formula, what I will get is, I will just write the result here. One will be cos omega m minus omega c into t plus cos omega m plus omega c into t. Actually here it should be. Now this is the final expression. This is the final expression. Here sign should be -1. Here the sign should be negative. Now what is the important point of discussion here? Then we will see that discussion with the support of diagram. Important point of discussion is carrier wave was AC sine omega ct. One frequency was carrier frequency before modulation. Omega c is carrier frequency. Omega m is the frequency of the signal. After modulation, there were only two frequencies before modulation, omega c and omega m. After modulation, we are having three frequencies. One is omega c, other frequency, you can say here it should be omega c minus omega n. Because why I am doing this thing? Because omega c is very high frequency, and that doesn't make much of the difference. Also remember this thing. Why that does not make difference? Because cos minus theta is cos theta. This is omega c minus omega m. Now we are having three frequencies. Before modulation, we were dealing with two frequency. After modulation, we are having three frequencies. This is the second frequency, which is less than omega c. Another frequency, this one, which is greater than omega c. It means after modulation, before modulation, only two frequencies, omega m and omega c and omega m. Remember, omega c is much greater than omega. After modulation, we are having three frequency. Omega c is the frequency of carrier wave, then omega c plus omega m, a frequency more than this, and the third frequency omega c minus omega m. Now here in the modulated wave, I am having three frequencies. Before modulation, we were having only two frequencies. One frequency was of carrier wave and other frequency was of modulating wave. Now let us have a look at the diagram. This is that part. I have just told you that we have got three frequencies. One frequency is, now this diagrammatical representation gives us a very good idea. This is omega c, is carrier frequency, and this is the frequency on the lesser side, and this is the frequency on the higher side. Now this is the band. You can very easily see this portion. This is basically, this length is twice of omega c, and this is called bandwidth, and this is called bandwidth. Now let us have a look on this part. We shall have a view of this part in diagrammatical fashion. Now this is to be understood. For example, here I am having AC is the amplitude of carrier wave. This is carrier wave. It is a high frequency carrier wave. Remember, this is high frequency carrier wave, and one ratio which I have used in the expression is omega. This is mu. Mu is ratio of AM by AC, and this ratio, this is called modulation index. This is called modulation index. Mu is modulation index. It's an important parameter, very important from examination point of view. And here, this is the module. This particularly is the modulating signal. AM is the amplitude here. Now we will put this wave on the lower part as well as on the upper part. See it here. The original, this is, remember again, carrier wave, modulating wave. This is the modulated wave, CMT. CMT is represented by this wave, which I have drawn as an expression, and CMT is basically complete expression. Here it is not written, I have written above. This is the complete expression, omega c minus omega m, omega c plus omega m. Now let us have a look like this. Now this is that modulating wave is put on the upper part, positive axis, positive y-axis. So we get a wave like this. AM is amplitude of modulating wave, and here this is A max, A maximum, and this particular part is you can say this part is A min, and we shall be calculating the value of A max and A min in my next lecture. You just observe that we have put this modulating signal on the positive y-axis as well as on the negative y-axis. In the upper part we got this way like this, and in the lower part we again got a modulating signal. Modulating signal is put in the positive y-axis side as well as on the negative y-axis side, and we got this bead-like structure. Now again, this is carrier wave, this is modulating wave, and this is the modulated wave which is transmitted. This wave is transmitted. You can easily write. This wave is transmitted by the transmitter to the channel. This wave is transmitted to the channel. Transmittable wave. This is basically transmittable wave. And in the next lecture, I will again start from here because we have to deal with these 2 or 3 very important issues. And this lecture and the next coming lecture, it is very much important from examination point of view, and I request all of you to attend this lecture.